Just just have a search.
Yeah.
Probably you would find that video which I saw.
Okay.
Yeah, I think it was in the UK again.
All right. So talking about the robotics that we were talking about, you've written some journals for uni life and education wise.
Yes, some of my work was published in one in a conference and another one in a journal.
And what were they?
Yeah, so basically the conference paper which I wrote was I was the co-author, and it was into biologically inspired robotics. So what you do is what biologically inspired robotics is what it is you take inspiration from nature and you try to build some sort of a robotic machine.
Like what? Example?
So it was mainly focused on this bird called a guillemot.
A guillemot.
Yeah.
Okay.
It's small. It's the bird is something like a small duck. And the bird can fly and dive into water.
Okay.
As well, and I mean, so it could travel in two mediums, one in air and one in water. And if you think that in the robotic context, a flying machine like that would be hugely beneficial, say in offshore rescue operations, where you can fly the robot from the beach. You can send it up to if it's
a drowning person.
Yeah, if it's a drowning person, for example, and if you want to see what's underneath the water or something, you can just fly it out and make it.
What I like about it is just not that you're doing something and innovating something just for the sake of it, but it actually helps the people in the real world.
It is. I mean,
it does have a internal connection.
Yes, it does. So one of that was one of the. I mean, that's the wider picture,
Yeah.
But there is so much to be done to get there. So basically, what I was doing was so birds have a lot of really interesting characteristics in their wings.
Yeah.
So for the bird to fly from air to and go back into water, there's a huge difference in the density. So air is much less dense than water, almost I think 800 times. Water is 800 times dense. So what I was doing was trying to develop a wing for the machine, and it had to be flexible. And you take a normal aircraft wing, it's flexible to a certain extent, but not in the context how birds change the orientation of the wing or anything like that. So yeah, that was one of it.
Okay.
And then for my master's, it was a totally different thing, but again on biologically inspired robotics. So basically I was studying about the cockroach, and if you really read about the cockroach, it's amazing. You'd come to know what an amazing creature it is. You can just chop the head off of a cockroach, but still the body will work. So the cockroach basically it's
So you've tried it.
Well, I'm pretty sure you have, because you hit a cockroach, but you still see
I don't
you
hit
don't.
Cockroaches.
Okay.
I'm very innocent. Okay, don't accuse me, man. I'm kidding.
Well, I mean, you might have seen someone else do it. So I mean,
true. Especially ladies at that.
Yeah. So you hit the cockroach, it won't die at the first shot.
Yeah.
So what I was trying to do was, so the idea is like, even if the control system is chopped off, the cockroach can still do work. So
you've studied the characteristics and how it works out, and then you apply that here, is it?
Yes. So basically, the cockroach can operate in a very decentralized manner. So the body is decentralized to the head, that sort of thing. So this I was given the task of incorporating these features into a robot that can again do rescue operations.
Okay.
But with a different technology. So the most common way of actuating something is to use a motor. But this actuator, it's sort of a muscle-like actuator. So it's got it's very difficult, put it in layman's language. But well, essentially what it's trying to do is a motor is very stiff.
Yeah.
Right. So if you give in a current or something, it'll just keep it'll just keep turning, or you cannot stop. But something like a muscle. Yeah. Say I push your hand or something. There's some sort of passive resistance. So these muscles, these artificial muscles, had that. So what I was trying to do was use those actuators to try to make a robot walk.
Okay.
Yeah. So
you succeeded in it, is it?
Well, to a certain extent. But again, it's research. So
yeah.
There's a lot more to be done. So I had about 6 to 8 months to do it.
Okay.
And I could have continued it, but I just did.
Research never ends, I assume.
Research never ends.
Yeah.
It's just.
And you've been an active participant in so many researchers, I would assume.
Yes, I have. I have about 3 research projects back at uni.
Okay. If you could briefly explain each of them.
Yeah. So 2 of them was that, and the other one was to make a gripping machine. So these all these projects, like it's you don't handle one single part. So the project itself is divided into different parts.
Okay.
So I was doing one part of it, and the whole idea about it was to make a gripping device that is very flexible. So again, inspiration was from the octopus. So the octopus can send its tentacles to grab an object very firmly and pull it close to the guy's mouth. So what we were trying to do is that because it's when robots and humans come together, the main problem is about safety, because if you were a robot and I was human, you cannot think in the human context. So you need to have that flexibility to stop major accidents.
Okay.
So this was going to be used in that context, and it's called human robot HRI, human robot interaction.
Okay.
So that was a part of human robot. It is something eventually going to be used in that context. I don't know if it makes sense, but
it did to a large degree, yes.
Okay.
But I think
it's very difficult, to not explain it in using engineering.
But I kind of understood what you're trying to say, and this is a hypothetical question that I'm sure a lot of people would be thinking right now. In the long term, artificial intelligence, like in the movie, think it's possible? The very, very long term, yes. Where you could have human-like robots playing humans themselves. It will be like a complete new race. Is it possible?
Well, you've got robots playing football now.
Sorry?
Robots playing football. In Bristol there was, I don't know if it happens yearly, but there was this. It's called a Robot Football World Cup. So it's like FIFA.
Okay.
FIFA, whatever. This is a Robot World Cup. So what people do is, students from different universities in different countries, they make their own robots, and they try and play a game of football.
football game is going to be coming again on the show. We need you back on Good Morning Sri Lanka, all right?
Okay.
Because this conversation didn't end here, because so much more is coming up. Thank you, Pastor. Thanks a lot for the chat. It's been a blast, and we wish you all the best for your future endeavors.
Thank you very much.
Well, Good Morning Sri Lanka unfortunately has to wrap up today. Join our Facebook site as well. It's www.facebook.com/goodmorningsri Lanka. Banu out. Have a great day ahead, guys.